Hello, and welcome to my presentation on real-time personalization with Sitecore JSS and Azure. My name is Bas Lijten, and I'm a 5-time Sitecore MVP and work as a lead architect within the Microsoft Portal and Web API domain for Achmea, the largest insurance company within the Netherlands. Achmea itself does not sell insurances or other financial products, but we have several brands and labels who do this. All of these brands share the same architecture, but it doesn't mean that they run on the same infrastructure. For example, they all run their own Sitecore environments, so we can update them independently, but there is a common reuse of blueprints, architecture, and shared components. Fun fact, we have 150 of those Sitecore instances up and running in Azure, with just 4 employees working on the operations part of it. Today, I'm going to share some thoughts on real-time personalization. What is it? Our architecture, some required Sitecore modifications, followed up by the cool stuff. How can you incorporate those real-time updates? Let's first take a look at what real-time personalization is. So what is real-time personalization? I'll try to explain this with 2 examples, using a small demo. You are currently looking at a regular Sitecore MVC web application, with all the default content shown, no personalizations. In order to show a personalization, customer has to do 2 things. He has to interact with your website, and he has to refresh the page or to navigate to another one. Let's imagine that this user triggered a goal. Based on that goal, we let an external decision engine decide to show information about a new service that we offer and send that decision to the XDB for usage within Sitecore. Nothing happened so far. Only after the customer refreshes this page, the personalization will be shown. Things would get better if you could update the content or components remotely. And this is exactly what we have done. Take a look at this example. This is a JSS application, which represents a very complex funnel. Want to calculate a car insurance premium, for example. Based on mouse behavior, we could detect if this user had problems filling in the correct data, or if a customer would close the browser. In these cases, we would like to offer help. It would be great if we could offer functionality to immediately start a chat or to offer a call as soon as a call agent would be available. Based on the behavior of this customer, the engine makes a decision to offer a Call Me Now personalization. And see what happened? The page altered in an instant. And this is what we call real-time personalization. Being able to update a page without having to refresh it or even interact with it. So why did we require real-time personalization? In our websites, we have many complex interactions. These interactions might be touch points where customers can leave the website, although we try to design them to be as simple as possible. In some cases, we want to offer help using an intervention, for example, a chatbot, a Call Me Now button, or an option to schedule a phone call. These interventions might differ based on the audience the user resides in, the time of the day of the week, and whether or not a call agent is available. A totally different intervention might be possible as well, for example, by sending an email. In our architecture, we have placed a decision engine which can compute the next best action for a customer. This decision engine uses a centralized data store with user info and is able to push those next best actions to different channels. If you look closely, it looks a little bit like the setup of Sitecore, where marketing automation fulfills the decisioning role and XDB fulfills the data store. This doesn't mean that there is no room for the XDB and marketing automation. The decisions of the NBA engine are sent to the XDB, which acts as a cache for the decision engine. This prevents very chatty traffic with the engine and ensures performance, as the XDB lives close to the Sitecore instance. For channel-specific interactions, marketing automation could still be used, and due to this setup, we can still make use of the power of Sitecore. Everything that I'm going to tell in this presentation is not specific to this architecture. If you would like to make use of marketing automation as your decisioning engine, the things that I'm going to tell you still apply. In order to be able to consume next best actions, or NBAs for short, a few modifications have to be made to Sitecore. The first step is to be able to store one or more NBAs into the XDB. We created a custom xConnect facet to store all the MBAs. The most important parts are the name, context, and treatment. These will be used in custom conditions. The second step was to build this custom condition to get the specific MBA facets from the XDB for a contact and determine whether or not that decision is applicable for this page. This way, the power of Sitecore personalization and the content management capabilities can still be used, while the actual decisions are abstracted away. This means that marketeers can define complex strategies in our decisioning engine, while only the outcomes can be consumed by our content editors, using the content editor or the experience editor. The biggest change that we had to make is residing in this part. Take a look at this diagram and try to determine why. Our external decision engine can push new MBAs at any time during a website visit. The default working of Sitecore is that the XDB contact and its facets only get loaded at the start of the session. This means that the engine can send out MBAs whenever it wants. Sitecore will not consume them. We could have made the choice to query the engine directly, but from an availability and performance view, we decided that it was better to use the XDB as the MBA store and query the XDB over and over again, as opposed to the decisioning engine. In order to achieve this, we added a few lines of code to the pipeline. On every page request, we removed the current contact from the session. From Sitecore 901 and onwards, the contact would automatically be reloaded again on the next request, but this was not fast enough. By immediately reloading the contact and its facets into the current session, we are sure that we have the latest set of MBAs available for usage. This gives a very small performance overhead, but it can nowhere be compared to query the external decisioning engine. To summarize these modifications, on every request, we reload the contact into the current session and its facets from the XDB, which can be used in a personalization rule to determine whether or not a personalization should be shown. For more information on reloading XDB data, I would recommend to visit my blog, which can be found at the end of the slide deck. Now, let's take another look at the real-time personalization. At the moment that I send out a new MBA to the Sitecore XDB, the application gets updated instantly. And this, my friends, is where we see the combined power of Azure and Sitecore JSS. As I told you before, we do not inject custom JavaScript or content. So what kind of magic are we using? It's called SignalR, real-time web functionality to update connected clients without pulling the server. SignalR is based on WebSockets, and via a central hub, messages can be sent to clients. This can happen for all connected clients, for a group of clients, or for a single client. Updating the single client is very powerful, as we can send a notification to the client, "Dear client of user X," which can, for example, be identified by the XDB tracker ID, which is also available in the SC Global Analytics cookie. Here is a message especially for you. The message can contain just a signal that something has happened, content or whatsoever. We chose to send out a signal so we could manage content in a single place, Sitecore. Let's dive a little bit deeper into it. Our decisioning engine sends MBAs for a user to xConnect and identifies this user by that XDB tracker ID. As SignalR has a public endpoint, keys were exchanged so the decisioning engine, and this can be marketing automation as well, can send out messages to the Azure SignalR hub. These keys need to stay secure. Based on a message sent to the Azure SignalR endpoint, SignalR knows what to do. In this case, SignalR sends out a message to this specific client. On its turn, the client requests a new view of the page. And do you remember those 3 Sitecore modifications? As we added the possibility to reload XDB data, the new MBA will be retrieved upon that request. As we are requesting a new representation of this page, the personalization engine, using the custom MBA condition, will do its job and return a personalization if one of the rules matched. Sounds a lot like standard Sitecore, isn't it? Of course, SignalR has to know what clients are connected and how they can be reached. In other words, a client needs to subscribe itself. But how could this work when SignalR can't be accessed without having one of those access keys? The solution lays on Azure Functions. We have generated a negotiation endpoint. This Azure function is accessed using the secure key to Azure SignalR. When the client wants to negotiate for a SignalR subscription, the Azure function will tunnel that request to SignalR. SignalR responds with a secure JOLT token and the subscription URL. The client can use a JOLT token and subscription URL to execute the actual registration. Let's take a deep dive into how this works by breaking down the example that I showed in the first and second demo. I start out with a JSS application without any personalized content. I opened up the developer toolbar and I executed a hard refresh, so every resource will be reloaded. To filter out irrelevant resources, I selected only the XHR requests. The first thing to show is a JSS response. A single component with two fields is shown. The next action is to subscribe to the Azure SignalR Hub. This consists of two parts. Connect to the Azure function to negotiate. I am running an Azure Functions emulator locally, hence the localhost hostname. This method returns an access token and the URL of the actual SignalR service. The second part is the actual registration on the client. The JSS application connects to the URL that was provided by the Azure function and sends out an authorization header with the provided JOLT token. The response contains information on different transport methods and a connection ID. Now this chain has been executed, the client has been subscribed to the SignalR Hub. Let's imagine that the engine has sent out a new MBA to xConnect and a personalization notification to SignalR, as we have just seen before in the architecture diagram. When taking a look at the signal traffic, we do see along the keep alive messages an actual message, new personalization available. Nothing more, nothing less. And this is the trigger for the JSS application to send out a new request to Sitecore. And if we take a closer look at the page representation, we don't see that single component anymore, but the second one has been added. One that was triggered to show by our personalization rule. And I hear you think, whoa, this all sounds complex. Bas must be a genius. Well, I got news for you. I am not a genius, and it wasn't that hard to implement at all. Make a guess on how many lines of code I wrote for the JSS application and for the Azure function to get this to work. Hint, make a guess below 25. Let's take a look at the code that we had to write on JSS and for the Azure function. Let's start out with the Azure function. The code that you see is everything that was needed in order to set up the new negotiation between the client and SignalR. Microsoft offers some marvelous Azure function bindings to get this to work. Please take note of the user ID. Using dynamic binding, we can bind a specific HTTP header to the SignalR user ID, which is used to send updates to each individual. In our case, the XDB tracker ID that was previously mentioned has been used for this identification. The same ID is also used by the decision engine to send out MBAs. At last, but not least, the JSS code. You are finally looking at the piece of code where all the magic is happening. To be able to use SignalR, the ASP.NET SignalR node module has been added, which offers us the possibility to set up a SignalR Hub connection. This is only a few lines of code. To be honest, I cheated a little bit by omitting the code to set the XDB tracker ID header. This can be found on my blog as well. And do you remember the part where I showed how the new message was received via WebSockets? Well, take note of the third line, where the function call to the new message will be executed whenever this new message has been received. The second highlight shows out the logic that is being executed whenever this function is triggered. All we do is reloading the JSS page and rebind it to the context. And these two blocks of code cause the real-time personalization. This brings us almost to the end of the presentation. Let me summarize what we have learned in the last 50 minutes. I shared our definition on real-time personalization, the ability to immediately update a page without interaction in that page. A decision engine is used to push MBAs to xConnect. This could be an external decision engine or marketing automation. The The three Sitecore modifications that we had to make are a custom xConnect facet, a custom condition which compares MBAs in order to apply personalization, and a method to reload the XDB contact on every page request in order to load those MBAs into the session. We have learned that we use SignalR to push notifications to our browser and that we need an Azure function to set up negotiation between the browser and SignalR. And after implementing all these prerequisites, JSS can react to that SignalR message and reload the current page. Because Sitecore retrieves the XDB data with its NBA facets, the personalization pipeline will be triggered and determine whether or not to render a personalization. JSS rebinds that view to its context, and voila, the page gets updated without interaction. Thank you for attending my session, and I really hope that you got inspired, at least a little bit.
Thank you everyone for watching this presentation. We hope you find it useful. We are live from our home offices, and we have here Bas. Hello Bas, thank you for your presentation.
Yeah, thank you for watching to my presentation. I hope you learned something from it.
Absolutely. We have a couple of questions, but if you do have a question, please submit it through the question panel on the right. So the first question, can you please help us where we can find your blog?
Yeah, I forgot to include it in my slide deck. My blog can be found on blog.baslijten.com. I hope I won't have to spell it. But if you have any questions or want to have extra insight regarding this presentation, you can find it over there.
All right, the first real question is here. So, have you had any issues with firewalls blocking the ports needed for SignalR? If so, how do you handle these scenarios?
No, we didn't have any issues. From what I remember, it's just running over HTTP for Azure SignalR, that is. So you might have to unblock the Azure SignalR services. But more than that, we didn't face any issues.
Okay. The scenario, what you described, is it only like a proof of concept, or did you try it in a production environment?
No, it's not a proof of concept anymore, but it's not running in production yet. We have to work some details, but well, we hope to have this into production in a few months. Okay.
And did you do any performance testing on this solution? Are there any bottlenecks, or do you need to do anything special on the Sitecore server side?
No. Well, what a bottleneck could be, as I told in the session, could be reloading the contact, the XDB contact into the session database. That has to be tested thoroughly, but more than that, it is not too strange of a solution. SignalR is well implemented by Microsoft, of course. So only performance bottleneck could be the contact loading.
Okay, sounds good. Next question. Do you have any ideas how it could integrate with IoT devices, this solution?
That's an excellent question. I really don't know about the use case and the context that you're asking this question for. So I really can't answer this question right now.
Okay, no problem. But I guess any device which can invoke SignalR commands can also receive some information from the server, and the device can interpret.
You could connect any IoT device to SignalR and transfer information to it. There are other protocols for that as well, of course, but it could be applied.
Okay. Would it be usable for chatbot integration on a website?
Yeah, this SignalR technology that, well, all the samples that you see are especially made for chatbots or chat rooms or whatsoever. So for async traffic, this is an excellent solution, especially when you want to trigger a single person or just a small group of persons in a secure fashion.
Okay, we have some more time, so if you have more questions, please do not hesitate to submit the questions through the question panel on the right, and Bas will be happy to answer them.
Yeah, another question I could come up with myself is how I was talking about an external decision engine, and how could that engine be triggered? If you're thinking about it from an omnichannel context, any trigger can be used to trigger that decision engine. If you're taking the web context, then you could think of, for example, Sitecore goals. And if you would use the Sitecore goals and mark them as a live event, then you could immediately, after triggering that goal, send out the trigger to the external decision engine to have that real-time conversation with the engine.
Okay, we got a couple of questions, which is great. The first one is, how are active sessions handled during code deployment when Sitecore needs to restart?
That's an excellent question. I think that's more a question in general. It's not specific to this use case. You could shut down your service gracefully, of course. But we mainly have deployments which are not at the most crowded hours. So we have the luxury to just, kill those sessions and restart them. Most of the data is not in the session itself, by the way, in our situation. So we have the login cookies are still valid. The contexts are reloaded into the session database. So that's not too much of an issue. And we don't have any other custom data apart from that in our session database. So apart from that, that's how we handle that.
We got a couple of more excellent questions. One of them is from Irvin. Thank you, Irvin, for your question. Do you have to pre-model your XDB contact facets or interactions?
Yeah, we had to create a custom facet to store those next best actions into. So we had to provision those facets to Sitecore and to XDB, to the xConnect server, I have to say. And whenever it's there, we can just fill any contact with the custom facets. In case of new contacts, so when they don't exist in the XDB yet, then we have to make another call to the XDB to explicitly create that contact. It's just a part of the XDB API that you can use within Sitecore or remote. And then you can send any facet to that contact whenever you want at any moment.
Okay, Eric come up with a question that this solution requires JSS. If yes, which version?
Any version of JSS.
Okay. And this concept can be leveraged outside of the JSX context?
That's a very hard question. Yes, it can be done, but you would have to handle your page updates in a very smart way. And not to reload the complete document because it would require a complete new page view. And the good part about JSS is that you can do partially page refreshes. But, it can be done, but it would be harder to implement.
Okay. Next question from Mark. Thank you for your question, Mark. Could you please explain again briefly why the negotiation function on Azure is needed?
Yeah, it's hard to do without slides, but the Azure SignalR function is open to basically anyone. And the administration part of it is behind, well, it's open to anyone as well. So it's behind some security keys. To add a new person to that SignalR service, you would have to acquire those administration rights to add someone. And that single administration service, basically, which is open to anyone, basically has that administration key, that secret key, as part of its service, which is not available to the outer world. So it can do the negotiation for you. That's why the negotiation service is needed in Azure Functions. And I hope that I answered his question correctly for that. Well, that I gave the answer to the correct question. Sorry for that.
Yeah, I hope so too.
Yeah.
We got a comment and a question from Meng. I want to say that it was an impressive demo, and it's nice to see cutting-edge technology like this. And as a related question, what are your thoughts on Blazor server, which also uses SignalR?
Sorry, I really can't answer that question because I don't have too much knowledge on Blazor. Fun fact, my colleague is talking about Blazor all the time, so I really have to dig into it. But if you want to exchange thoughts, feel free to get in touch with me. No problem.
All right. Maybe you can do a blog post later on about it.
Yeah. Maybe. Yeah.
All right. The next one is any security concerns for negotiation Azure Functions, as anyone can call the service and register itself to the SignalR?
That might be a problem for you, but if that's a problem, then you can just use this this functionality. Maybe what I could come up with is to upload some of that functionality to Sitecore to handle it as a proxy in between. But we do not think that's too much of an issue. A lot of websites do have open APIs as well, which aren't too much of a problem. The only thing that would happen is, as this Azure service, that it would increase the costs. So you would have to put some web application firewall or whatever in front of it for API management or any other mitigation that you can come up with.
Right, thank you.
Good question. Yeah.
Hopefully. And if not, they can reach out to you, I guess, through your blog or through Twitter and on Slack.
Yeah. Yes. Yeah, that's right.
And, thank you, everyone, for asking questions. And thank you, Bas, again, for your presentation. With that, we conclude this live Q&A. And all the best for all the other sessions.
Thank you as well for watching here.